good. All right. New section for the new test unit. And a lot of you need to do better on this test than you did the last one. Actually, almost every single one of you. Today is the beginning of you doing better on that test. Today is the day that if you have any questions, you're going to start to ask them. I can't see into your brain. I've tried it. Okay? I need you to speak up if you don't understand something. I also expect you to be finishing your homework before you come to school and not rushing to do it during activity. The reason for that is this. In the morning, you can ask me questions if you have them from finished homework. Or you have almost everything finished and then you ask questions. Okay? One of the ways that I've explained to people is if you're going to be swinging on a swing set, you have to pump your feet first and then I can push you. Okay? You have to get the swing moving a little bit. All right? I'm very weak. No, because I need you to start it. As in, I need you to do the homework and start with the homework so you have a specific question. Because I don't get it is unacceptable. That's a statement. Okay? Is that clear? Keep in mind that this math class, you're supposed to be memorizing things just as you do memorize things in other classes. This isn't like the younger math where you're just like, answer. Question, answer. Okay? It's not the thought process like this. Part 1, look at question. Part 2, think really hard. Part 3, write down answer. Okay? No. All right? You have to apply what we've been doing, and if there's something you don't understand, you need to ask me. That's my job. Come see me during activity, that sort of thing. Last several days, we've been doing stuff with ordered pairs and graphing, and that is the precursor to what we're doing today. Relations and uptown functions. See what I did there? See, it was like topical. Because I'm hip. I'm so hip. There. The hip old dude.
Amazing spelling.
Hip old dude. Okay. I'm just so hip and happening. Now, relations and uptown functions, section 8-1 in your book for those that if you aren't turning in your book tomorrow. A relation is a set of ordered pairs. A relation is a set of ordered pairs. For example, 5, 7 and -3, 12. That's what we've been doing the last couple of days of class, and we made the ordered pairs and connected them. So it's a set of ordered pairs. So these are a relation, okay? It's a set of ordered pairs. There's a relation there is 5 and 7. It has both an x-axis and a y-axis from what we've been doing. Then we have more names for them. Specifically, a domain is the first set of data. A domain is the first set of data. So, for example, 5 and -3. What? Okay. 5 and -3. If you want, you can just do the bracket like rather than having a parenthesis, do a bracket. You don't have to do the squiggly bracket. You can just do the one that's boxy, like this. Or. On a graph, we always label the domain on the x-axis. We always label the domain on the x-axis. Always. So, in this ordered pair, this is a really tough one, circle the first set of data in 23:14. Which one am I going to circle, Noah? Yes. Ooh, tough stuff. Okay. The domain. Let's see. Is the first set and x-axis on graph. So it's just rewording it. The first set of data and x-axis on graph. X-axis on graph. Whoops, hello, what did I just do? On a graph, yep. It's the first set, and it's also the x-axis on a graph. But you knew that second part. You've seen that for years. Home on the range is the second set of data. On the graph, we always label the range on the y-axis. We always label the range on the y-axis. Sorry. And here's another tough one, really hard. Circle the second set of data. It's not that one. It's this one here, because it's second. Yeah. I did. I need to fix some of it, though, because I did it myself. Thanks. I'm also going no gel today. Yeah, it's cheaper that way. The range is the second set and the y-axis. The range is the second set and the y-axis. A function is when each domain in a relation is paired with a range. And if it's in an urban setting, it's an uptown function. And they're going to give it to you. Example 1. Graph the set of ordered pairs. So we're going to do this one together, even though, we've been doing this for days. So it says graph the set of ordered pairs. My first one is 1, 3. So I'm going to go 1, 1, 2, 3. And I'm going to put that right there. Then it goes. Go ahead and I'm just going to talk YouTube through this. Go ahead and you guys order those or graph those. Next one is 5, -5. So I go to 5 on the x, and then it's -5. So I'll shoot down to -5 here. Then it is -4, 2. So 1, 2, 3, 4, 1, 2. Then we have, what did I just do? No, that's not it. 5, -5, -4, 0. That's it, sorry. -4, 0. 2, -3, 1, 2, 1, 2, 3. -5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. -5, -4. So I have those points that are labeled or graphed out. Yours should look like that, exactly like that. Maybe not in blue, it should be in pencil. I'll make these bigger for what we're doing next. There. Easier to see? Now, for the domain of this guy, to list the domain. Now, what is the domain again? What is the domain? Yeah. The first set of numbers. So I'm going to back out here so we can see both of them at the same time. says here the first set of numbers. And the way that we're going to do that is we're going to list all take care. We're going to list all the x values. We're going to list all the x values of this up here, down here. So I'm going to need to move this up so I can actually, no, I'll sit on the floor, I don't care. There. So all the x values, I just list them as they are, because it's 1, 3, 5, negative 5, negative 4, 2, or 4, 0, 2, negative 3, and negative 5, negative 4. So there's my domain. I'm just listing out the x values. Then it says, what is the range? We're going to do the same thing, but now with the y values. I'm going to make my bracket. 3, negative 5, 0, negative 3, negative 4. And if we were doing this in reverse, all we need to do is see whatever values that x takes up right there for the domains and y's for the ranges. Okay? Any questions about that? No? Let's do another example. Graph each relation. Now, in order to do this, to make it look more like what we're familiar, let's make this into a set of ordered pairs. So I want you to write first, make into a relation of ordered pairs. First, we're going to make it into a relation of ordered pairs. So to make this into a relation of ordered pairs, I have 6, 0, 3, 8, 6, negative 1, negative 2, 3. So I'm just taking the x values and the corresponding y values to make it into a relation. So there's only 4 there, so let's label those, or graph those. You can just go on the top for 8. So yours should look like that. Yep. The first one. 6, 0. You did 0, 6. You did 0, 6. Cheater. All right. Now I want you to do this one. I'm going to do it up here. You do it down there. Then when you're done, you could look up here. So you're going to be writing them again as a set of ordered pairs. And can you guys please rewrite this number 2 here as 3? Rewrite it as 3 so the next questions don't confuse you. Okay, got those? All right. So we're going to skip the next 2 blanks before we can know what it is, because we don't know yet. We don't know if it's a function. We haven't learned that. So the vertical line test. The vertical line test. Can be used to make sure a relation is also a function. And I always second guess myself when I write the word vertical. So in the past I've spelled it vertical. Does anybody have confidence that I spelled it right that time? Okay, Google. Vertical. Rats. Okay. Darn. Darn. Hello. Vertical. The vertical line test can be sure the relationship is also a function. The vertical line test, vertical line test, uses any straight edge to determine if there is a function by making sure the vertical line passes through no more than 1 point. I want you to circle that. No more than 1 point on the graph at the same time. So it's a vertical line that goes through no more than 1 point at a time. No more than 1 point at a time. And the way that you're going to do this is you're going to be able to just gently fold your paper over and see if it's going to go through that. I have my shade that we're going to find out if examples 1 and 2, so now we're going to be doing this one, find out if examples 1 and 2 are in fact functions. So here's example 1. I'm going to take my vertical line. Let's get this out of here. You over there. You over there. So I'm going to take my vertical line, and we're going to see if this is a function. If it hits more than 1 dot at a time, it's not a function. So, boop. Is it hitting? How many dots is it hitting?
1.
Just 1. Boop. 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 Is it a function? Yes, it is. It is a function. So, how about this guy? Example number 2. Here we go. Boop. We're good. Boop. We're good. Look, I'm hitting 2 at the same time. Okay? And the way that you would do this with your page is if you would softly fold over that page, you can have it go through there. Just make sure that you're having it. So you're going to be having your paper like this, and you're going to fold it over onto itself like that when you're doing a graph. And you just move it that direction, making sure it stays horizontal, like that drawing. Okay. That's right. So we found that which one? Is it number 1 or number 2 that is a function? Remember, number 1 did not have it hit multiple dots at the same time. Okay? Yes. Number 1 is a function. Yes. Number 1. I'm number 1. Yeah. No, number 1 is a function because it did not. Because it did not. See this right here? It says no more than 1 point. Exactly. That's why number 1 is a function, because it did not hit more than one dot at a time using the vertical line test. That's why you circled what I just pointed to. See on the lower left of the screen? Because through vertical line test, only hit 1 point at a time. I'll zoom out. Let me just hit 1. Because it only hit 1 point at a time. View 50. There we go. Yes, sir. Yes. Yes, it will be on the test. Yes. I don't show it to you if it's not going to be. Yes. Did not have more than what?
Did not hit no more than one dot at a time.
Sure. That works. Yes. Cool. As I said at the beginning of class, next Friday. Yes.
Did this one hit 2 dots at a time?
Nope, sure did not. Let's do it again. Number 1. Vertical line test. Commencing. Boop, just 1. Boop, just 1. Boop, just 1. Oh, that guy's close, but boop, just 1. This one, however, boop, boop, okay. All right. The sound of a chicken sounded appropriate. Now we're going to be graphing all the possibilities of getting a 7 with 2 die. So we have 2 die, or 2 dice. So we're going to have our set of ordered pairs be the numbers that could show up on a die to get a sum of 7 between 2 dice. So what's one of the sets of ordered pairs that you could get a 7? Orfino? 5 and 2. Beautiful. Yes. 3 and 4. Yeah. 6 and 1. Is that it? Yes. There we go. 4 and 3. Sydney? 1 and 6. Noah? 2 and 5. So go ahead and graph those points, please. That's not necessary. So what is the domain for this set of data, for these relations? Yes, I'm good. Okay, so 5. I'm going to draw my caret. 5, 3, 6, 2, 4, Good one. And I'm going to do the range. I put those in order just because, let's say that I was looking at it from just the graph. I know that there's a 1, a 2, a 3, a 4, a 5, and a 6. Oops. Now, is the relation a function? Vertical line test gonna give it to you. Boop, 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 boop. Yay! Is it a function or not? Yes, it is. It is a function if they're not getting too much traffic along the axes. So is this a relation? Is this relation a function? Yes. It's a functional relation. Are there any questions about the vertical line test, telling whether something's a function, ordered pairs, graphing on a coordinate plane? Okay. No? Wonderful.